Hello. Hi, Sujit. Sorry, I was late. Okay, so without taking any time, we can start now.
Sure, we don't want to wait very less participants, and so want to go ahead or wait for them.
It's already 9:10, I think. 10 minutes we are ahead. So we can start.
Yeah. Okay. Because I've seen in the questions, like in comprehension of ML, they are asking the question, please someone explain in detail what exactly the data is about. And I've explained them like 3 times in the lecture itself. So if they're not here, then how do you, it will be very difficult for me to repeat things, no? So I'm going to repeat it. And I will expect you guys also to not tell them what the data is about, because it is told in the lecture. If they are smart enough not to come to the lecture, then they should understand the statements from the problem statement itself, if they don't need any further explanation. Right. So on the other day, I missed that topic last time, which was the confusion matrix. So I'm going to talk you through the confusion matrix first, and then whatever I discussed last time about the logistic regression. We discussed about a sigmoid function, which was 1 by 1 plus e to the power minus x. And we looked at the corner values as well, that if it is x reaches to as high as infinity, this will be equal to theta parameter will be run to 1. And if it is going to as negative infinity, it will go to 0. And if it is, the value is 1, then we will have, when it is 0, it will be 1 plus 1, 0.5. Okay. So now we'll go ahead and we'll start with understanding the confusion matrix, and then we will go ahead with the logistic regression in detail and understanding how does it update and progresses the weights as well. Not weights, but like training the logistic regression. Okay. Additionally, I just want to ask you guys beforehand that you attended the lecture session yesterday. And so was it helpful? You guys were able to clear your doubts and implement your model? If it was helpful, you can show me a thumbs up so that I can think of this again in the future after converting to sessions, covering few sessions. So you would prefer this sort of thing after every session, right? Okay. Then we'll do this thing on a 2 or 3 times. And once we reach to the stage where we are doing deep learning and other stuff, then we'll stick to the specific lectures itself and try to understand things up. So I expect you are able to see my screen, and it is about the confusing matrix, correct? I don't know which screen I'm sharing actually, that's why.
Yeah, because of confusion matrix.
Okay, so screen 2, share. Right, so now let's try to go through the confusion matrix. So confusion matrix, we generally calculate to see the outcome of a trained model in terms of not only what is the accuracy is, but for each classes, was it able to predict it was a false prediction or it was a correct prediction. So that you have, if you have 2 classes, let's say positive and negative, sorry, if you have, yeah. So if you have, let's say that you have a data set where you have, let's say a simple data set as cancer, and telling that you have a cancer or not, and also the doctor's input as cancer or not. So now when you go for, so what's your ground truth is you have a cancer or not, and what's the predicted truth is prediction is what doctor made a prediction. Now, if we want to draw a confusion matrix of that, it will be one, doctor predicted that you have a cancer and you have cancer. Then sorry, I do not have my iPad today with me, so I'm just using my mouse here. Okay, so it will be true positive. So if you have, so whatever you made and it was correctly a statement that you said yes you have a cancer, and doctor said yes you have a cancer, so it's a true positive. If doctor said you have, doctor predicted if you do not have a cancer, and yeah, and your results came out and you saw that you do not have a cancer, it's a true negative. Okay. Now the false positive is type 1 error, where the doctor said that you have a cancer, but your result came out as no, you don't have a cancer. Additionally, when the false negative, doctor predicted that you do not have the cancer, and your results came out as yes, you have a cancer. So that's a false negative, right? So this is a confusion matrix that we generally compute in order to calculate many of the things in the machine learning or in validating any model. It is very important. And on basis of this as well, if you will study some papers and other stuff, you will see people calculating kappa values and other stuff, which comes from this confusion matrix itself. So I'll just go ahead with a very basic. Right. So here we can, as you can see very clearly, that you have, I'm using confusion matrix for a scalar. So you have a scalar input confusion matrix, y prediction equal to k and not made users. If you can forget about it, just trying to plot here. So you can look at it and you can see that when it was class 0, it was predicted class 0 and it was true class 0. So there was only 146 cases. When it was a class 1 and it was a class 1, it was 42 cases. Okay. So the total will be 146 plus 42. You have total correct predictions, right? Then the false positive would be, he predicted this and this cause output, so it would be 21, and then cases, and then you have 47 cases. Okay. So now, if you are going to calculate it, yeah. Sorry, every time forget it. So here you have, so then you have this case, which is 146, 121, 47, and 42, right? So then there is a confusion matrix. Is it used only for classification problems? It's not classification of them. It's a matrix. So confusion matrix is a matrix to analyze what is the accuracy of the model is, or precision of the model is. So here we are trying to do again the same thing, which is y prediction. We predicted on the basis of the X test, and we are you have, this is the same representation of what data you have here. So 146 is here, 21 is here, then 47 is here, and then 42 is here. Okay. Now precision score, positive and false positive. So true positive and false positive, the first row. Okay. So precision is will be the precision equal to true positive divided by true positive plus false positive. So the precision of the model will be this value divided by this value plus this value. Okay. So the precision of the model we will calculate here from here. So it will be 146 plus 21. Sorry, 146 divided by 146 plus 21, which will be 146 divided by 167.
Sujit.
Then yes.
Someone is asking, can we use? We can use confusion matrix only when we have to predict. We have two prediction categories. Is it right or not?
No, it's not right actually. Yeah, so I think TAs are replying to it. If I'm not looking at chat, you can ignore it. So you can so this is like it's simple matrix. If you remember from your class, as I've done in previous as well. You have two classes. That's why you have structure like this: A, I, and J. If you will have three, then you will have three different. So it will be 3 by 3, 4 by 4, 5 by 5. It will increase by that size. Okay.
Okay,
So
guys, if
now
you're
the recall score.
just guys, if you are not satisfied with the answer, then please unmute and then ask in detail. Okay, go ahead.
Precision score, then you have the recall score, and recall score is false negative. Then recall is true positive by true positive plus false negative. So recall would be true. To calculate the F1 score, similarly, we will use the confusion matrix. So F1 score takes into account calculate the precision and recall, you will be getting the output from that. You can recall F1 score and stuff. Okay. So this is about the confusion matrix. Now, can you give me a thumbs up? Yeah, perfect.
Yes, sir.
Yeah. So we discussed logistic regression yesterday, and we derived it as well, and we saw how we can go from linear regression to the out. You can check in the playlist itself. Just for the PGANC concept, the last video is not added to the playlist. Course. So the logistic regression is used because we are applying another function to the weighted sum of input data and parameters of the model, and this plus e raised to minus x. So which is here. So if just to repeat again, if the x goes from so x can be in the side of the negative minus so in the case of minus negative, it will be equal to 0. Okay, tends towards 0. Now if it is to find the y value, okay. So now to calculate the logistic, so I'll just drop this one into the Slack. I'm extremely sorry, I forgot completely. So we will read the CSV file here, which is social networks.csv. So this is the data. We have user ID, gender, age, estimated salary, and purchased. for age and purchased. So we are going to use the scatter plot. This is the same fundamental we have used before. So this is the one. So you want to normalize the data. So you just use the x minus x mean and you normalize the data. And now you have x, which is the age is here. Then you are doing the same thing that we did before, which was the train test split into from x. And we are using a ratio of 1/3 again for, and then we are using not defined. So you can just use it. Is it up defined now? We are using the sklearn function for this one. And we will be using the train test split from sklearn, or are we using our own definition? Train test split. So we are using our own definition here. Okay. Let's see. Okay. So you can add this specific line into it, which is the sklearn dot model collection import train test split in your specific line in this one. And then you have this scatter plot, and then we go ahead, we normalize the data, we have the data, then we do the splitting. So we have now x train, x test, y train, and y test. So now we have to perform the logistic regression, right? So in this case, I'll explain you this whole algorithm. So since you attended the last lecture, you saw the derivation. So now to have the loss function, right? So the loss function okay. So to say the loss function, we have to, so this is how the logistic regression is going to update itself. So let's say that your actual value is something, which is your y. This is your actual value. And then one value will be your predicted value. Okay, so what we are going to make a prediction through the model. So you have to calculate that the model. You have to actually, what you have to do is you have to find the actual difference between the actual and the predicted value, which we are doing here. Then you have to square the difference, okay, and find the sum across all the training data. So that you have to do, right? So if I want to just denote that, I'm extremely sorry for not having my tablet today. So it will be like the loss function can be treated as L is equal to sigma. It will be for all the natural numbers, obviously. So it will go for y minus y prediction square. Okay. I hope it is clear. So this is what will be your loss function. Now, when you have to do this loss function, so you have to find the sum and update this all parameters and everything. So now you will be like, where does this thing comes out? Which is minus 2 by sum by y prediction into y pred. So what you are going to do here is we are going to use the gradient descent algorithm. So it's like to update the value. So we use gradient descent, the first derivative. You have to calculate the first derivative. So we also know that this yi is actually, y prediction is nothing. It is a prediction made on the basis of sigmoid function, which is 1 by 1 plus e raised to power minus x. So this is your prediction function. So if I replace this value with the binomial expression that I was discussing the other day, then you will be able to solve this one, which will be 1 by 1 plus e raised to the power minus b naught plus b1 xi. Okay, so initially we have given b0 and b1. We'll try to update this b0 and b1. So gradient descent actually basically will use this concept to estimate the parameters here by minimizing the loss function, right? So we have to minimize this loss function. So now once we have that, so what we have to go, so in gradient descent, what we do is we actually try to calculate the partial derivative, okay? So we try to calculate, we will try to calculate the partial derivative here, and we will have, I'll just start writing here. So we'll try to calculate the partial derivative with respect to b0 and b1, trying to minimize both of the stuff. And so once you try to calculate this partial derivative, which was, I just said, of this loss function, which was you will come up as if you would do it with respect to the b0, replacing this with the 1 by 1 plus e raised to power minus b0 plus b1x I. So with respect to this, you will be having minus 2 with sigma, and then y minus your y prediction multiply by y prediction multiplied by 1 minus y prediction. Okay, so this is what your when you solve the derivative here, you will be able to find out, okay, with respect to b0. And now for b1, we'll calculate this partial derivative for b1, and then it will be equivalent to this one. So which can be also written as, it's the same thing. So there is nothing going to change here, which is 2 into partial derivative of y minus y1 and into yp into 1 minus yp, okay, and multiplied by xi. So because it was b1 x1, so it will be bi xi.
So just a minute. We are finding that B0, B1 and all those so that we could fit the sigmoid function onto the data.
Yeah, so to update those values in order to find the minimum. Yeah.
Okay, so how do we get this y predicted and all? Because we have not fitted the sigmoid curve onto the data. So how do we get this y predict?
Okay.
Beforehand?
So in the previously, what we are doing here is, so I'll just tell you this thing. Okay, good question. How are we going to do that? So if you look here, so what I'm trying to get here is b0 and b1, correct? This is the, and initially I have initialized them with b0 and b1. I have defined a learning rate to be 0.001. So the program will start with something. You have something initially, right? And then once you start calculating it, b0 and b1, you will have this one with respect to x. You will predict some with some prediction, which is here. So your x is given here as x train and y train. So you see here, so x train is your data, the y train is your label. It came here. X is your normalized data. You did some prediction, which can be a wrong prediction. It's a random model train. Let's say with a train with just noise, you have some prediction. Now you calculate this b0 and b1, and then you are updating them.
Okay.
And this is when your training starts. So it will happen for all the epochs. So for the first time, some value, let's say some random value came up, right? So let's say that for the first time, I'll just try to clear. Okay. So let's say for the first time, we got some value as 0.4. Okay, because it is sigma, it can come up to be any value. So now if I calculate the b0, this is my predicted value, and let's say my actual value was 1. right? So now what will be the db0 will be? So db0 will be minus 2 multiply, and you have to do the summation for all the y prediction or something like that for all the y prediction. So we are just going to look it for the one value. Let's say that you are just one value. So it will be 1 minus 0.4, which will be 0.6 multiplied by 0.4, and then multiplied by 1 minus again y prediction, which is 0.6. So now if I do this, so you will have 2 minus 2 multiplied by 6, 36. 36 multiplied by 4 will be 24, 124, right? So 0.0124. 0.124. This will be the output, right? No, sorry, 144, no? Right. So, and then it will be, the output of this will be minus 0.288. Okay. So this will be db0 and db1. Then you calculate the b0 by b0 minus loss multiplied by db0. Okay. So this is how the b0 will be updated, and then b1, and then you will again go back to the top one, again keep on calculating. Okay. Our objective is to minimize this loss function. So we keep on going. So since our number of epochs defined is 300, we are going to do the same process 300 times. We'll keep on calculating this one. So, okay.
Yes, sir.
Okay. So this is how the loss function is calculated. If you want, like, if I hope you guys are, fine with the derivative. But if you are not familiar with the derivative, it's I can derive this for you as well. But right now I don't have my tablet, so it will be difficult for me to derive. So maybe if you want, you can drop me, and then I'll derive in the next class in front of you, or I can just drop the derivation in the Slack itself. Okay. So what we have seen here is very simple. Is that we have to find out the b0 and b1 value depending on, so given L. So L can be anything, which is, you can start with 0 point. L, you can say it's like a weighted multiplication. In the gradient descent, we call it a learning rate as well. But you can say it's a weighted multiplication. To minimize it, you can change it as well. You can also see that this L, that learning rate, is the way your model needs to learn. Slowly progress. When we are doing a normal classification problem as well, that you have seen, you have got in the terms of your competition and other data set, you will be able to see that these models, you can also create multiple models together. Okay, you can do multiple predictions together and multiply them with a special factor, and then add them as a prediction. Okay, so by this, what we do is we are doing a weighted prediction. So I want to make a prediction, so I will use KNN as well, I will use naive Bayes as well, and I will use logistic regression as well. But what I'm going to do is I'm going to multiply the so I'm going to multiply the KNN. I will want to multiply the KNN by 0.6. I want to multiply. We want to give naive Bayes a very basic, very low importance. So I'll multiply it by 0.01, and then I'll give logistic regression a more importance. I'll multiply it by 0.8. So now whatever output, weighted output will be there in the terms of prediction, you will get a weighted output. It's called an ensemble of model, you can call it as well. So they're combining all of the models together. This is the same way the learning rate is performing here in terms of gradient descent, right? It is trying to calculate the parameters in the weights, so that you weights, so that it is easy for you to go down, to minimize the loss actually. Okay, so let's see. Then you have here B0. So now whenever we are trying to find out the B0 and B1, we are going to perform the logistic regression, which is X train and Y train, given the data set that you have is already splitted between the X train and the Y train. So you have the output. Then what you're doing is you're doing the X test normalization using the normalize of the X test. Since you normalize the X train as well, normalization of the whole data set will be there. You should have normalized it beforehand, but it's okay. Yeah, you could do this all this thing together in the beginning itself, which is just when you're making the split, you normalize itself there only. So your test and train both are normalized at the same scale. Okay, so you don't need to actually normalize it here. This is wrong. So making prediction, and then you are going to make a prediction, which is y predict is equal to predict x test norm b0 and b1. So you have the b0 value, you have the b1 value, and then you have to make a prediction with the x test data, and you're going to get a y prediction. Y prediction is 1 if p is greater than 0.5, else 0 for, since we are doing sort of classification in 0 and 1. So if it is less than 0.5, we are making it a class 0. If it is greater than 0.5, then it is making it class 1. Okay. So we are now here trying to do a scatter plot, and we are looking at the prediction that we made and what is the accuracy that we got. The accuracy that we have received here is 88%. Okay. Now we do the same thing using the library. I hope I've been able to make you understand the model very clearly, that how it is doing. It is one of the most simplest Python program till now you might have come across, which is very simple arithmetic going on here. So using scikit-learn, you're just going to import a logistic regression from linear model, and then you have linear model is equal to logistic regression. Then you have linear model dot fit, which is so similarly as we were doing before with the library. I'm not much experienced with these sort of libraries. Generally, I write my own function. So if you have any problem in these libraries to implement or something, you can reach out to the TAs, or you can write it to me as well. I'll look at it. And I've told you already how to look for a specific library or their methods. So sklearn, it's famous library, scikit-learn. So you can, the scikit-learn library in the linear model, you have logistic regression defined. You're trying to import that. You created a model here by calling out the logistic regression. Then you're fitting the model by giving your x train, and then dot values reshape -1 to 1. Then y train values reshape -1 to 1. Then you are trying to make a prediction, where you're making a prediction just by calling the same model which is trained now is dot predict, which you did here in this process, y predict. So you're just going to do a prediction here, and then when you make a prediction, so you have a classifier, and then you're trying to show the accuracy as well as the scatter plot, which is almost same. So we did with this simple formula, we got the same values, and we did with this one, we got the same values. Okay. So that would be then it for today, and we would be able to. We have completed the logistic regression as well. Now I think moving ahead, we have to cover. Wait, let me open. So since you guys have already now did all able to implement them and now train your model as well. So I expect that you train your model today as well on the given data set, or on your old data set, or on the challenge data set, which I've already given you. I hope nobody has, right? Give me a thumbs up if you are fine with the challenge and understanding what you have to do in the challenge. Can you hear me, everybody? Okay. All right. So that would be it for today. You can go ahead and try logistic regression. I have already explained the mathematics. You can look at the last lectures, and then you can look at this one. And I've told you the gradient descent method, because you'll be going for the partial derivative, and then we calculate the partial derivative. You can try the derivative on your own, and then you can go ahead. Okay, if you have any other problem. Now, it is very simple models which are remaining is decision trees and SVM. So by this, we will be almost be able to complete our machine learning models, and we will go ahead for deep learning. So I want you guys to in practice, do we use libraries or prefer custom functions? Actually, it actually depends on this thing. You can use a library if you have no previous experience in Python programming or something. But since I'm a machine learning scientist, I generally tweak the model. So for if I want to tweak the model or I want to tweak the loss, then I just don't import the library or the direct loss. I use the mathematical formula to compute them and then tweak it accordingly, or design your own loss function. So sometimes you will see that it is straightforward. If you're not experienced, then you can use the standard library. It is pretty much standard and it has all the capabilities. It's correct as well. But since there are so many libraries, it's very difficult to remember all the time that what all libraries and what all other models will be there. So you can use any of the libraries and their specific methods to train this model and stuff. Custom functions, you can have your own custom functions if you want to go into those things. But if you are not experienced with the programming and you find it difficult, then you can go ahead with custom with your own, not with your own, but pre-designed libraries. But if you're going for the interviews or something, I would expect you to practice writing custom functions, because in any interview they will be asking you the mathematics behind any machine learning model and probably program it. So at that time, if they ask you to write a logistic regression, you can't do like sklearn from sklearn model selection import logistic regression. You have to write the logistic regression properly in the terms of stepwise what happened mathematically, and then you're calculating it, which I've shown you. So similarly in KNN, which might be the very common model to be asked in an interview, and there you can't again import the sklearn model. You need to write it as the steps that I have already shown you. Calculate Euclidean distance, sort them out, and then match the test data to see where it stands and then which class it belongs. Okay, so that will be it for today. Then see you in the next class. Thank you very much. Bye-bye.
So this is all for today.
Yeah, this is all for today. You're 4:15. Already completed 1 hour.
It's 9:45 now.
Oh, okay. Oh, sorry. Yeah. Yep. Yeah,
No
but
worry.
yeah,
You
this
have
is it for
completed
today.
your,
Actually, we'll cover the next.
I mean, for what you have prepared your material, and that if that's completed, then we can close. No issue. It's up to you for what you have prepared.
Can't understand, your voice is lagging so much. Yeah, but this is it for today. And this is it for today, and then we will next cover in the next lecture. So since it isn't continuous back-to-back class from the last 3 days, just go ahead and try these models out, and then we can see that tomorrow.
Yeah, one more thing, the people who are present here, I would like to make an announcement. Tentatively, we won't have any class for next 2 days because some people are asking that the schedule is being hectic. So that's why I am giving them a gap for 2 days. And also I have created a poll for that. So guys, please poll there. And tentatively, we won't have classes for next 2 days. And so you also can take rest.
I can, no problem with that. But we are about to finish up the model, machine learning models by maybe next class. I think it will be very straightforward, and we'll just finish it.
Actually,
okay. So and then we move to deep learning models, where the things will grow more interesting.
Yeah. Okay. See you in the
and
next
actually, I would expect everybody to actually just communicate it to your classmate, like your classmate or somebody, to please come to the class. They will come for 2 minutes and they'll go back. It's not for the attendance, no. And then they will ask the questions on the Slack that I don't understand this, I don't understand this. It was very foolish. Okay?
Yeah.
All right. Okay then. Thank you. Bye.
Okay. Bye, guys. Thank you all.